Good morning, ENGIANA class. We are the group 6 and we are here to discuss about a problem involving the Newton's cooling. Well, we are all familiar. The formula on Newton's cooling is this. The dt over d small t is equivalent to k times the difference between the T and the T sub 0, whereas T is the temperature of the body at any time. T sub 0 is the temperature of the surrounding. The small t, sorry for this, is the time, and K is the proportionality constant. So as an example, we prepare the problem. Say that the blood plasma is stored at 30 degrees Fahrenheit. Before it can be used, it must be at 90 degrees Fahrenheit. When the plasma is placed in an oven at 130 degrees Fahrenheit, it takes 40 minutes for the plasma to warm to 90 degrees Fahrenheit. Assume Newton's law of cooling applies. How long will it take the plasma to warm to 90 degrees Fahrenheit if the oven temperature is set at 99 degrees Fahrenheit? Discuss the problem, the solution to the problem. Mr. King and Mr. Adaya will be there to teach you. Thank you. I am Triple Tumambing. Going out.
Thank you, Mr. Tumambing. Now we're going to start to solve the problem. We are tasked to find the time it will take for plasma to reach 90 degrees when the oven is only set at 99 degrees Fahrenheit. Time start. You only have a time start, you have 0 minutes, and the plasma is stored at 30 degrees Fahrenheit, so it's the starting temperature of plasma. Given that the oven is set at 130 degrees Fahrenheit, it's the temperature of the surroundings. It takes 40 minutes for the plasma to heat up from 30 to 90 when the oven is set at 130, and we need to find the time it will take for the plasma to reach 30 to 90 when the oven is only set at 99 degrees Fahrenheit. Given that Newton's law of cooling applies, we have the equation dt over t minus t sub o is equal to k dt. We can solve this problem by definite integral because we are given two conditions. The integral of dt over t minus t sub o from 30 to 90 is equal to k to the integral of dt with values 0 to 40. Integrating the equations, we have ln t minus t sub o with values 30 to 90, and k which is the integral of dt with values 0 to 40. ln 90 minus 130 over 30 minus 130, and on the other side we have 40 minus 0 times k when we plug in the values. Further reducing it, we have ln 40 over 100 is equal to 40k. You can cancel values. 40 over 100, it would be 2 over 5. Dividing 40 to the other side, we can solve for k, which is equal to ln 2 over 5 over t. Thank you. Mr. Daya?
As what Professor King said, k equals ln 2/5 over 40. Now that we have our k, let us tabulate our new table, in which we need to find t at 90 degrees temperature in a surrounding temperature of 99 degrees Fahrenheit. So, using Newton's substitute our values. We will be using definite integral from 30 to 90 T minus Ts, which is our surrounding temperature is 99, equals the integration of k dt from 0 to t. Now that we have our formula, we can now solve by substituting all our values, including k. So ln of 9 over negative 69 is equals to KP, which is equals to ln of 3 over 23 over ln of 2 fifths over 40 is equals to t. From here, is equals to 88.919 minutes. And the problem